So yeah, welcome to my talk called Family Emojis Length equals 7. And yeah, it's actually my first talk at a conference, and not only my first talk, it's my first time being at a conference. So, but I really appreciate you voted for this talk, you came here, so thank you very much for that in advance. Okay, so a little bit about me. My name is Sven. I'm a Ruby backend developer and working at Zing since 2018. Now, some developers would tell you where to find them on Twitter. I am not on Twitter, not on Facebook or anything. If you're interested, if you want to get in touch, or if you have feedback, you can give me that on the Mastodon network. And my handle is Svedi, and I'm on the ruby.social server. Check it out if you haven't yet. So let's start with what this talk is all about. It's all about a challenge that my team faced, and yeah, what we learned from that and all the stuff that we encountered. And it's basically about this. You have a string, in this case the family emoji, and you want to count the characters. And the actual challenge is to count consistently across all platforms, being Android, iOS, web, and the Ruby backend. Yeah, and we didn't really care too much if we counted right. Like, if you count right, that's very, very subjective. Like, you could argue if it's right to say that the length of a family emoji is 7. So the thing that mattered to us was consistency. Yeah, so I will walk you at first about yeah, what you may think about when counting characters and how we concluded. So consider these characters like an accented Latin character, an emoji, pictograph, Chinese character, Devanagari text, a slightly more complex emoji, and Zalgo text. So if you're wondering what this is actually very similar to the accented E. Like for the accented E, there was an accent added to the E, and Zalgo text is driving that to the extreme, like adding a lot of stuff on top of characters. So now maybe you get a feeling of, okay, this may not be so trivial like you would have thought at the beginning, maybe. So let's take a look at first this character accented E. Now you could say, okay, an accented E is an accented E. That's one character with an accent on top. But you could also say, okay, it's an accent and it's an E, so it's 2 characters. And that's kind of the first decision you have to make, how to count that. And turns out people thought of that before, and they developed the so-called normal forms. Like the first one would be the composed normal form. So it's a composed character. And then there's the decomposed normal form, which would count these as 2 characters. And they are abbreviated as NFC for normal form composed and NFD, respectively. So we did a bit of research about these normal forms, and it turns out that on one hand, you can normalize strings in Ruby using this function. I'm passing the NFC symbol here, but that's not mandatory because the default is NFC, and it turns out, like almost everywhere, NFC is the default. Like the kind of the guys who invented character counting Twitter with their length limit for messages, they are counting in NFC. Everyone is doing it. So that was a simple decision to use the composed form. Now, yeah, one of my favorite topic, having been a PHP developer also before going to Ruby. So here's a couple of encodings that Ruby understands. There's actually a lot more encodings than that. These are just random encodings that I encountered throughout my career. But if you wonder which one to use, there's actually not many that you would consider. Like you want Unicode, you want to represent as many characters as possible, and UTF-32 is kind of odd. So, but UTF-16 and UTF-8 are used in a lot of places. So these were the encodings yeah, that we had to make a decision between them. And UTF-16 is actually the default for JavaScript, Kotlin, and the Cocoa framework, whereas UTF-8 is the default for Ruby and the web in general. And I found it quite interesting that the default for JavaScript and the default for web are actually different, but I don't know why. It's just interesting. So let's take a look at how counting characters works in these encodings. So UTF-8 being the default, counting an extended E, so this is normal form composed, so this is no surprise, it's 1. UTF-16, big surprise actually, this is again NFC, we would expect 1, so why is this 2? And this is where it got really weird counting in Ruby. So we did a bit of investigation, so show me the code points that this string is made up, and it's just 1, which is no surprise, 1 character, 1 code point, okay. And UTF-16, it's the same code point, but there's something prepended, and this is just strange. So what is this, and why are there 2 characters? So, here. So what is this thing? And yeah, at first it was weird, so we skipped to a more interesting topic and delayed this decision. Yeah, so now we get to the interesting stuff, emojis. Do you know the length of this? Oh, whoops. Sorry. Okay, but that was the simple one. Do you know the length of this emoji? In this case, I heard 3, that's right. So why is that? And if you if you look at the characters that this emoji is made up from, you realize it's composed. It's composed of different emojis, the female emoji and the school emoji, and in the middle there's an invisible character. I refer to it usually as the glue character that glues these emojis together. And you can basically glue any kind of emojis together with this character, and sometimes something new is created when you do that, like female plus school is female teacher. And now it also becomes possible to understand what the title of this talk is about. Yeah, it's 4 emojis and 3 glue characters. So this is why the length of this emoji is 7, at least in the default encoding, which is UTF-8. And as I realized that emojis have a different length, I was wondering, well, does it make sense? Does it make sense to count 1 emoji as several characters? And I was wondering if is there some kind of method that I can call on a string that counts every emoji as just 1. And it turns out there's something pretty handy. You can ask this string for its grapheme clusters and then count them. So what is a grapheme cluster? And the simplest explanation I found was a grapheme cluster is a user-perceived character. So, of course, every user would perceive this female teacher as 1 character, so it makes total sense that this is 1. But do we want to use that to count, really? Because consider we have to do this cross-platform, and Ruby has this handy method, but turns out, especially in browser JavaScript, this is really not as simple. This is not supported natively, so we couldn't use that and decided to count by characters. So to recap, we said we wanted to use NFC. That was simple. We count characters instead of grapheme clusters. So now, how about UTF-8 or UTF-16? And can you guess it? 8. And it is 8? 16? OK, let's recap. UTF-8 is the default for web and Ruby. UTF-16 is the default everywhere else. Counting UTF-8 is a bit clumsy in Kotlin and JavaScript, but doable. Counting UTF-16 in Ruby is just weird. Want to change your mind? We used UTF-16. So let me show you how this looks like. In JavaScript, we just call length. Android, the same. iOS, we just convert to UTF-16 and count the characters. And in Ruby, we've got this. Oh my God, what is this? So don't worry if you don't get immediately what this is doing, because I'm going to explain in detail. Pardon? We are getting there, yeah, right. So we were investigating strings in UTF-8 and UTF-16 to make sense of it. So if we look at the characters that an emoji is made of up in UTF-8, it's just the emoji, which makes total sense. And in UTF-16, it is this, which, wow, what is this? So we went on and investigated the bytes and found out, okay, an emoji is made up of 4 bytes in UTF-8, whereas the UTF-16 has 6 bytes. How can that be? How do you need 6 bytes to represent an emoji? But then we realized that if this is this, maybe this is this, and this is something strange represented here. So maybe this is something else than a character. Maybe this is, yeah. And it turns out it actually is. You said it's the byte order mark. So what is the byte order mark? Well, it does what it says. It tells in what order the bytes are to be interpreted. And to understand why we need that, it's something that we don't have in UTF-8, but UTF-16 requires that. And in order to understand it, you need to know there's big endian and little endian. So this is a MacBook that I'm using, so I'm using big endian, but other systems are using little endian, and they're ordering bytes differently. And we can take a look at if we convert to UTF-16 and say we want big endian, then we get the 4 bytes that we would expect from an emoji. And the same if we do this with little endian. Now, can you see the similarity between these two? It's actually the same bytes, just in reverse order. And the next thing we realized is, hey, this is something that we already know. And now it becomes clear that, okay, this UTF-16 always has this byte order mark followed by the actual characters. So let's recap. UTF-16 strings start with a byte order mark. The byte order mark is not a character. It specifies the order of the bytes. And Ruby does count the BOM anyway, like if it was a character. So why? Why, Ruby, do you do that? And the answer is, I don't know. Really, it doesn't make sense. And it turned out that all UTF-16 string lengths were just UTF-8 plus 1 for the byte order mark. And we were like, why? But I really couldn't find out. But yeah, so the challenge was not to count right, just consistently, okay, we go on. We need to find a different way to count UTF-16. So let's take a look at the history of UTF-16. So the predecessor is called UCS. And there's a very simple idea behind that. Someone said 2 bytes is enough to display all characters there are. Now, that sounds a bit like wishful thinking, but it actually makes things pretty simple. If that was the case, then we could use this algorithm. Just encode in UTF-16, count the bytes, subtract 2 for the byte order mark, and divide by 2, like 2 bytes is 1 character, divide by 2, and you get the character count. So, very nice idea. Unfortunately, it's not really possible to display any character with 2 bytes. Like, consider this. I learned the Chinese alphabet alone contains 50,000 characters. And 2 bytes is roughly like 65,000 characters that you could possibly represent. So, and there's a lot of languages in this world. So you get the idea that this might not work. But again, remember, the challenge was to count consistently. And it turns out this seems to be the way that JavaScript and all the other languages are actually counting characters in UTF-16. So, and that was, I think, the biggest surprise. Like an emoji, 4 bytes, is counted as 2 characters in JavaScript. This algorithm will return 2. And so this is what we ended up using. So, yeah. Since we got a lot of time, first of all, thank you. I just saw we've got quite a lot of time left, so are there any questions? Yes?
So in all the in the whole talk, it seems like it's always a conflict between consistency and making sense. And at the end, you seem to have favored a consistent solution. Doesn't it really depend on what this count is used for? Because sometimes it is more important to make sense.
Absolutely, yes. In this case, like think of this use case, you want to validate a maximum length, and you want to display how many characters are left. And maybe the iOS client says, okay, you've got 3 characters left. You try to save, and then the backend says, boom, backend validation, it's too long. Like it was about preventing this. But if, for instance, you have, like you're using, say, MySQL, you have a constraint, a string can only hold 255 characters, then don't use what I showed to you. Use the normal string count. Yeah.
Can I ask you to repeat the question so we get it on tape?
Sure.
Not for this one, for the next one.
Okay. Yeah.
How the databases actually do it. So if I imagine having a validation in place that says, right, this is 140 characters, for example, and I have a constraint on my database column that says it's at most 140 characters, and use so basically, what does the column use as counting character? Do you have any experience with that?
Okay, so the question was how databases count characters. And to tell the truth, I didn't investigate. And my pragmatic solution would actually be to not put the constraint, to put the validation in front, but not the constraint, so nothing can go wrong. So we're safe. But no, I didn't investigate that, but an interesting topic, definitely. Yes?
When you have 16 little endian or big endian as encoding, the size seems to be correct. So why didn't you use this and instead count the bytes and subtract the 2?
Yes, I believe that would have been definitely possible. So actually, but we first came up with this algorithm, and then I did some more research into that. But yeah, it would definitely be possible.
Maybe this was because that on the other platforms, because they count that way you back engineered that they did it other way back, more complex examples or something like this.
Mm-hmm.
So that's what I was thinking about.
Okay. Yes?
You ended talking about all this system is based on the premise that all the characters use 2 bytes. But you already saw as examples that 2 bytes are not enough. But still you are using this approach. How this end up working in production when there is a character that uses 4 bytes or something.
Yeah, so the question was that at first there was this premise that every character has 2 bytes in UTF-16. But I explained there are characters with 4 bytes, so how does that work out in production? Yeah, so we investigated that actually all the other languages did the same. So if JavaScript says an emoji which is made up of 4 bytes is 2 characters, then that's all right. So the
It's only consistent among languages, which are worried about, not the real characters.
yeah, as I said in the beginning, what's right or wrong when counting characters is pretty subjective. So.
And maybe you mean that all the Chinese people are used that they only can type 70 characters in Twitter. All the Chinese and Thai people are probably used that they only can type 70 characters in Twitter.
Yeah.
140 by now.
Yeah, now I'm afraid.
That's the reason.
Actually, we had some tests. We had a lot of different characters, and we were running tests on all platforms how long they would be. And I showed one Chinese character at the beginning, and its length was actually no wait, it was 1 in UTF-8. But could be, yeah. Wait, a good question. Yeah. We did some investigation on how Twitter counted characters, and it was even different. Like every emoji on Twitter was 2 characters, I think, on Android. And I don't know why that was. So they have something different. But officially, they say they count NFC UTF-8. So, yeah. Yeah.
Did you raise an issue with Ruby for the counting, or try to fix it yourself? And
So we didn't fix it ourselves, but I was wondering. Yeah, I considered doing that, and I still considered doing that afterwards. And yeah, maybe so that could be my first kind of little contribution to Ruby.
So thank you very much. Just give another round of applause. Yeah, UTF stuff is always mind-boggling. Every talk I've watched about this was always blowing my mind, so this is cool. The next talk that was supposed to be in this room is actually not a talk and not in this room, so this is cool. So there will be a fishbowl discussion about estimates, and that's going to happen in the cafe upstairs above the forum. So if you want to go there, please. This also means that we're probably shutting down this room for the next session. So yeah, that's it